Hands. We use them for everything: typing, eating, waving, and well, let's just say they are versatile tools. Now, before your imagination runs wild, let's stay focused. That's not what I meant. So please get your heads out of the gutter. Anyways, today we will keep building on what we did in the previous tutorial, animating virtual hand meshes using OpenXR hand tracking data. If you're new to this series, I highly recommend checking out the first video before diving into this one. We have already covered the fundamentals of hand tracking using OpenXR and Unreal Engine, which you'll need to understand before this tutorial. In order to keep the video duration short, I've decided to split the second tutorial into two parts, which we'll discuss in a bit. So it's time to grab your VR headset, fire up Unreal Engine, and let's get started. If you remember from the first tutorial, basically what we did, whenever we were running the VR template, we modified it in a way that we were able to move our hands in front of the HMD or your Quest headset. And we were able to replicate the movements of the hand using cubes in the VR template, and also we were able to do gesture detection. Whenever we were doing a pinch, we were able to basically draw a particle and use that to draw inside the scene. So that's what we learned in the first tutorial. And if, as I said, you are new to this series, I highly recommend you go watch the first tutorial. If you go to my website at babai.net, and for example, if you go to the archives, you'll find this tutorial here. And there you could find a link to the English video tutorial and also the Farsi one. And in addition to that, you could find the project files, the project source code on my GitLab or Microsoft Azure DevOps repositories. But getting that out of the way, now in this tutorial, I'm going to close this one. In the new tutorial, what am I going to do? Basically, I want to animate the virtual hand meshes that are shipped with the VR template. You can find them inside VR template, or I think it's inside character, mannequin, and here inside meshes, you see two sets of hands. One is called SkeletalMeshComponent left and right, which is like a male hand. And the other one is called Queen, which is basically set of female hands. Whichever you prefer, it does not matter. You can animate both and using the techniques that we provide here. And basically what we want to do, let me run my sample project here. I have to run it in VR. Basically what I want to do is I want to animate the virtual hand meshes the same way I did with the cube, and also I do want to have the gesture detection as well. And in addition to that, I would also like, for example, whenever I pick up the controller, my Quest controllers, now it should switch to the hands animated by the VR template, which uses a different approach. It uses anim sequence and also animation blueprint, and the hand movements basically are restricted to the animation they've designed inside these this VR template. But also in addition to that, whenever I put down the controllers, now I can switch to hand tracking very smoothly. So you should be able to switch between these hands using the motion controller or using the hand tracking, as you can see here. And in addition to that, also whenever I press the D key on my keyboard, I would like to have these debug gizmos, which basically is going to help me debug the code I've written for the animation. It's just basically we are going to draw one of these gizmos per joint, as you can see here, and it's just a very helpful thing during the development and working with the hand joints data. So if I press D again, it's going to turn off. That's basically what we are going to do. In the first part of the tutorial, I'm going to focus on drawing those gizmos, being able to use that feature to debug the hand, and also being able to switch between the controller and virtual hand meshes smoothly. But I'm not gonna animate any hand in the first part. In the second part, we're gonna animate the hand and copy over the code we've written for the gesture detection in the first template, in the first project or tutorial, and we use it in this new tutorial. So basically that's what we are going to cover in this tutorial. So let's get started. What am I gonna do? I'm gonna move this to my other monitor. I might be using it. But what I'm gonna do, basically, you are going to run your Epic launcher, and from there, once you've done that, just run Unreal Engine 5.5, because what I'm going to write here, it's going to work only on 5.5, but we did cover basically in the previous tutorial how to use the same code between Unreal Engine 4.26 up to 5.4, because there were some API changes. And we already did discuss that, but it should be really easy. Like, it should only take you 5 minutes to make the project compatible with the older versions. But since Unreal Engine is not binary compatible with the older versions, whatever I create in the newer engine versions, you cannot open it in the previous one. But I prefer to use 5.5. As I said, there is no difference, and basically changing the code should be really easy if you follow the first tutorial. But let's launch the Unreal Engine 5.5, and once we are inside Unreal Engine project browser here, go to games, go to virtual reality with the starter content, and this is the path I'm going to create the project. I'm gonna call it XR Hands Animate Mesh Animation, which probably I already do have. Then I'm gonna call it EN. It says the project name is too long. Then I'm gonna call it Mesh Animate 2, which should be fine. And then create the project. It's opening up in my first monitor, but I'm gonna move it to the second one. Okay. Now, if I run the project here in the VR preview, now there is no hand tracking. As you can see, I can see the hands. One of them is on the floor, the other one in mid-air, because basically it's just the location it syncs my controllers out, because I did put them on the table, so they were deactivated. But now if I pick them up, basically these hands are animated for the controller, and there's no hand tracking here. If I put them down, you can see them. I am moving my hands in the air, and you can basically nothing happens. So let's go back into Unreal Engine. If you go back to characters, mannequin, and meshes, as I said, the meshes are here. The way Unreal Engine does animate these meshes, basically it's just going to use these animation sequences, which you can animate them, for example, inside Maya, Max, or whatever. And before that, I go here, make this open in the main window, because it just makes our lives easier. And as you can see, it's just a single frame. Unreal Engine basically blends between those poses using something called here, if you go inside meshes, called animation blueprint. This animation blueprint is basically the proper way to, the best place to animate any skeletal meshes. But we are going to avoid it. If I want to animate this virtual hand in C++, I'm going to use the equivalent of this, which is called AnimInstance proxy. And I'm going to do it here because everything you do here is going to run in the animation thread, which is more optimized. And basically, it's just the preferred way to do it in Unreal Engine. But in this tutorial, specifically because I'm using Blueprint, it's less flexible than C++. I'm going to do it from the game thread, and I'm gonna avoid that totally because here there's something called modify transform modify bone. If we want to use that like programmatically, when we choose that, there's no way to programmatically specify which bone I want to animate, and we have like 26 of these joints per hand. And basically I cannot specify this programmatically. I have to duplicate all these codes, and it just gets really complicated. But in C++ I can do it, and I prefer to do it here. But for now, we just bypass this AnimBP, and instead we use a different kind of mesh than the skeletal mesh. Let me reload this because I don't want to modify this. So basically what we're gonna do, these meshes, these are basically, if you go to Unreal Engine's VRTemplate inside Blueprint and come into VRPawn, here, basically, if you take a look at these meshes, and if you basically look at the type for these, I'm not sure if I can do it here. These are of type U skeletal mesh component, which we cannot modify from outside the game thread. If we do that inside the animation thread, sorry, if we do that, the game is going to crash. But there's a special kind of skeletal mesh, which is called PosableMeshComponent. And we can use this one to basically modify the joints of the mesh in order to animate the hand programmatically. But there are some differences between these, we will see. By default, you have the skeletal mesh component, which is this one, hand left and hand right. These are the ones basically Unreal Engine uses when we use the controller inside the game wall. Right now, these are basically hand left and hand right, which are controlled using the controller. If I move my right controller up, it's just gonna follow that. And if I move my left controller, it's just gonna follow that. But we want to basically switch between controllers and hand tracking. That's what we want to do. So the first step, then we do the rest of the programming inside this VRPawn, because whenever we run the game, one of these is going to be spawned inside the game. And there are already plenty of functionality here. For example, I can use teleporting, or I can use the left controller to basically rotate here and use the right controller to teleport inside my game wall. I can also pick up guns and basically fire the gun around, and yeah, this kind of stuff that you could do, and you can drop it. There's a bit of functionality there. Also, you can interact with other objects like the cubes that you see here and stuff. But for now, let's go back. We just want to go inside VRPawn, and here there's already some code for you. It's already commented what these parts do, but we don't care about all this stuff. We want to write our own functionality. So the first thing I'm gonna do, first I make sure I've clicked on the VR origin, because as you can see, these components are like a child to basically the pawn. And also, as you can see, for example, for the motion controller left, the hand left, the mesh is attached to the motion controller left. That's why whenever I move the motion controller, the mesh of the left hand, for example, moves. Or if I move the other one, which is called motion controller right grip, basically this one is going to move. And also, in addition to that, there's a component here called XR device visualization right. I believe there was something called is visualization active. For example, let's enable this as well and compile the code. Let's rerun. Maybe actually that's a good thing, help us to debug better. And as you can see, you see the controllers. Now they are inside my hand, and it's just going to visualize the controllers for you as well, which is a nice thing. Basically, we are going to keep this on for the rest of the tutorial because it's going to help us distinguish between the hands that are using the motion controller for their movement and animation and hands that are basically using the hand tracking and stuff. So that's one other thing that is nice to have. And I'm going to save this. So it was this XR device visualization. But anyway, as I said, you go to the VR origin, and in there, make sure you are on this one because you want to make the hand a child of this VR origin, not, for example, child of this one. So make sure you are at the correct place. Then click this add type PosableMesh. Once it's added, I'm going to call it XR hand left. In order to distinguish it from hand left, I'm going to call it XR. Again, I click on VR origin. I'm going to add another posable mesh, and I'm going to call it XR hand right. And once I did that, I'm going to choose the left one. I go here, it's hidden inside the mesh. Basically, it's collapsed. I'm going to expand it. It's called a skeletal mesh. You can always also search here. If you cannot find it, for example, it's like this. You type a skeletal mesh and you will find it here. Anyways, I'm going to choose the same hand mesh, the one that is called SkeletalMeshComponent left for the left hand. And for the other one, I'm going to use XR, basically SkeletalMeshComponent right. And let's compile and save. And something should happen probably. Let's see. And inside the game world, if you look at, for example, my controller, these basically this is the right hand, and the other one is this one. If it's able to pick it up, it's not getting. It's basically the other one. But as you can see on the ground, there are basically two hands. You see them at the origin of the world, which we attach to the VR origin. It's at 0, 0, 0. Now we see those hands that we have added, which are of type posable mesh. It's at the bottom of the world that we have, and we have the other hands here. As you can see, I'm moving them. But right now, we don't move the other ones. It's at the bottom of the basically scene. So let's go back inside the VRPawn. So now we did add them inside here. Now the first thing I want to do, whenever my game begins, there's an event here called event BeginPlay. I'm gonna grab this and move it all the way here. So I've created enough space in between. Maybe that's too much. Yeah, I think, yeah, this is good. So what am I gonna do? Basically, I will write a function. That function is going to detect which basically source of animation I should be using. For example, the motion controller, they are active. If they are active, I'm going to use this one. If the hand tracking is active, I'm going to show the other mesh and hide the other one. So that's basically what we want to achieve. But at the beginning of the game, at event begin play, I want to basically rely on the motion controller. And at the beginning, I want to hide the meshes at the basically VR origin at the bottom of the scene on the floor. So I'm gonna grab this XR hand left here, and then I'm gonna type set visibility, which I can basically set the visibility to false here. If I check it, it's going to be visible. If I uncheck it, it's going to be hidden. And then there's another one, XR, basically hand write. Also, you could, there's another function set hidden in game, and that's the difference thing. We are not going for that. But there are multiple ways that you can do this thing, and there are differences between them. But for now, let's stick to the set visibility. Also, there is another one called toggle visibility, which is going to invert it every time you use it. But now we use set visibility to explicitly disable, basically hide the XR hand left and XR hand right. I'm gonna grab this using control. Let's bring this here as well, connect them. And now we should be good to go, I guess. Compile, I'm gonna save it. And let me put my headset again. And here, if I come inside the game world, and if I take a look at the bottom, I can only see the two meshes basically from the motion controller. If I move the motion controller, you see them, they come here because it just detects the motion controller movement and they move here, but I don't see any sign of the other two hand meshes. Again, if you want to verify that, I'm gonna close the VR preview. I'm gonna go back and I just basically make these visible. As you can see, instead of hiding them, I'm gonna make them visible. So now I should be seeing basically four hands, two pairs of hands basically. And when I move these two, the other two, basically they are overlapping. They are at the bottom of my game, as you can see them downstairs. So anyway, I'm gonna go back and make these false. So we got this out of the way. Now we go all the way up here because we need a lot of space. I'm gonna add event tick, and inside this event tick, I'm gonna basically have a sequence of commands that I want to run. We will add these, basically you can always add pin and add more. We will need a few of these, but in the first one, in the first sequence of command, I'm going to run inside the tick command. Basically what I do is, let's also, whatever we modify, we comment this. I'm gonna press C. I say make the hand tracking meshes hidden. At the beginning. So this is it. Then we go back here. What I want to do, I will define a function. I will call that function, let's call it update, for example, hands visibility. And inside that function, if I compile it, so there should be no errors here. I want to have an input. As the input, I would like to have the virtual hand mesh. Sorry, I would like to have the controller, which basically controller hand I'm going to animate. And then from there, let's add, call it hand. This is the input basically here. I'm gonna call it eController hand. And once I do that, what I do, basically, the first thing I'm gonna do is to also, in addition to this, I need the hand meshes. So what am I gonna do here? Basically, I'm going to call it motion controller hand, but it's going to be of type, as I said, U. Maybe we don't need the U, it's not C++. We call U skeletal mesh component, which is this one. Then we will need another one, which is the hand tracking mesh. I'm going to call this hand tracking mesh. And this was, if you remember, of type PosableMeshComponent. Let's compile this. Go back to the event graph. Inside this event tick, I'm gonna grab one of these update hand visibility here. Let's see. Basically, what we want to do is we want to update the mesh visibility based on whether we do the hand tracking or the motion controller is active. But we want to do it per hand. We want to write this function to basically determine that hand, which mesh for that hand should be visible. Is it hand left or right? And also we should give it the instances of, for example, here, I one time do it for hand left, one time we do it for the XR hand left. And these were of different types. If you remember, we said this one is of type SkeletalMeshComponent, something that Unreal uses by default. And the other one, which we added using this add button here, which was XR hand left, which is of type posable mesh component. As you can see here, we determined the input type for this update visibility. Then I'm gonna basically do the same thing, duplicate this using Control D, but this time I'm going to make this hand right. So then I'm gonna bring this one here. Also, we made sure this one is right, the hand, and then the XR hand right, which is this one. So now I can basically connect this to sequence 1. And here I'm gonna double click here a bit, basically make these wires look nicer. I'm gonna move this a bit. Let's move that also a bit. And maybe we did go up a bit. So then I'm gonna comment these and I will add, okay. Let's say, for example, determine which hand meshes should be visible, whatever. Then basically based off of that, we decide which of those hand meshes we are going to basically show. Then inside the function, let's implement this. But the first thing I want to do is I want to basically define local variables, cache these for later use because we are not going to use these right away. So what am I gonna do? Basically, I'm gonna right click on this, promote to local variable. I'm gonna call it motion controller hand mesh. And we cache it here as a local variable. Make sure that you, whenever you right click here, do not choose promote to variable because it's going to be accessible in all functions inside this blueprint. What I want to do is make it local variable, which is accessible only inside this function. And then basically rename the other one. I can move this a bit as well. So basically I'm gonna connect these. First I cache the first one, then the second one, which I'm going to rename. I'm going to call it hand tracking hand mesh. And once I do that, I will comment these as well. I'm gonna say cache the hand meshes. Then what I do basically from the hand, I'm going to get the hand tracking status. If you remember, in older Unreal Engine versions, it was get motion controller data from the first tutorial. I'm not gonna explain what the data format looks like, what are the basically the properties on this node that is going to return to us. You have to watch the first tutorial for that. But anyway, let's make this a bit cleaner, like this. And maybe a bit like that as well. Then, what am I gonna do here? Connect this node to the other one, which means after we cache the meshes, then we are going to get the hand tracking instead. Also, since we are running it inside this function, we need to have a world context for this. From this world context, basically, Unreal Engine, most of the function is just blueprint functions. They require this world context because it wants to retrieve information from that that it requires for its functionality. So you have to define a world context. Basically, it could be any actor inside the scene, any U object. And then you could add, for example, the pawn itself, the VRPawn, or the player controller. And also, if you come here, it just like gives you a description. It says any object in the world. The player pawn would work as well. But what I'm going to do usually, I'm going to get player controller, and I'm going to get the first player controller, which is at index 0. For most of local players, it's just basically fine. In multiplayer games, you have more player controllers, but we basically, for our use case, the player at index 0 is okay. And then once we get that, we are going to break the data as we saw in the other tutorials. As I said, I'm not gonna go through everything here because we already did explain this. Now, after basically we cache the virtual hand meshes, we grab the data, but we should do some validation if you remember, okay? The first thing was to see if the data is valid. And then the second thing that we want to do, we want to determine which mesh are we gonna show. For that, we should check the tracking status. Basically, see if the hand tracking is tracked, then we are going to show the hand meshes. And also if it's not tracked, then we know it's the motion controller, basically hand meshes. So here I'm gonna say if I'm gonna do an AND Boolean because basically I want to have I want to press check if it's valid and the tracking status basically is something that I need. So I'm gonna type equal equal. It just shows me this equal enum, and here I'm gonna basically say tracked. Also, you have inertial only, but for now we just care about the track. If it's fully tracked, the hand tracking, then basically I'm gonna feed it to this one. So that means I have two conditions. The first condition is the hand tracking data is valid. The second condition is its tracking status is being tracked. If it's like that, then I want to show the basically hand mesh for the hand tracking. If not, then I use the other ones. And so now we use the cached basically meshes. I'm gonna grab one of these, get hand tracking mesh. Then I want to call the set visibility on this one, and basically I'm gonna connect the output of that to this one, like the new visibility, because the thing is, if it's also false, it's going to make this hidden. If it's true, it's going to make this visible. That's why I'm using the basically value of this condition here. Okay, that's it. Then for the other one, I'm gonna drag another one. We want to use not Boolean type not Boolean, it's going to basically this one, if it's true, it's going to make it false. If it's false, it's going to make it true. Because what we want to do basically is have the motion controller. Basically, let's go back here. Let's set the visibility for this one first. Maybe then I will explain what happens. Okay, let's go back maybe here. Just reorder things nicely. I can select them, use Q to basically orient them in horizontally. Then what I want to do is I'm going to connect, basically after we get the hand tracking status, we connect it to the set visibility for this motion controller hand. And maybe we have to organize things a bit better. I guess we can do that. But anyway, it's probably obvious what am I doing here. So let's see. Let's recap at the beginning. Okay, what we do, we say update hand visibility. We cache the hand meshes, the two hand meshes that are input to the function. Inside these two variables, motion controller hand mesh, hand tracking hand mesh. And here, basically after this caching, I'm going to get the hand tracking state. And for that, I need to specify a world context, which, as I said, get player controller is going to work. Then here, I'm gonna get the data. And then what I can do, actually, I can comment this. I'm gonna say get the hand tracking data. So here I know I'm getting the hand tracking. Then basically here, I'm gonna do validation. Okay, or I can maybe basically comment the whole thing as one. Maybe Control Z. I'm going to say set each virtual hand's visibility based on the tracking status. So as I said, if the data for hand tracking is valid and if it's basically being tracked, like the tracking status is tracked, then what we're gonna do here, basically set the visibility of the hand tracking mesh to whatever the result of this condition is, which was two conditions that we just mentioned. But for the other one, we want to do vice versa. Basically, if we make this one visible, we make the other one hidden. So that's why we use a not to flip the result of the AND result. And if this one is false, it's going to basically show the motion controller mesh and make the other one invisible. That's what we do inside this function. Anyway, let's test this because we already, I think, did it in the event graph. Yes, it should be working. Let's see. Let's go inside the game. Oops, I'm out of the basically MetaQuest app. So that's why you see a flat screen. I have to wait. It's inside. Now I'm gonna do VR preview. And as you can see at the bottom of the page, I do have this basically set of meshes. If I pick these up, basically I can see that, and then I cannot see the other two, which were basically the hand tracking meshes. So here I can basically, I have these, but whenever I put them down and I move my hands in front of the, as you can see, the front of the headset, now I can see the virtual hand meshes from the hand tracking. The other two, I can see the controllers because I did activate the location to be visualized, but I don't see the hand meshes. As long as I move my hands in front of the headset, they are there, But for example, if I hide my hands behind my back, I can see the hands from the motion controller. I bring my backs in front of the basically headset, you see my hands. So it's just working. Or if I move the basically motion controllers, it does not matter if my hands are in the picture. They are still hidden, as you can see. So basically we achieved the first thing that we wanted. Now it's time to basically draw the virtual hand mesh that we want. Okay, now what am I gonna do? I'm gonna go back here. What I want to do is basically have a draw virtual hand function. And inside that draw virtual hand function, I would like to basically specify which hand I'm going to basically draw. So let's say draw, let's name it draw debug virtual hand. And inside this, I want to basically have as parameter the hand, which is of type eController hand. I'm going to use the compile button. And as you can see here, I can specify left or right. And what I want to do, basically, if I go back to the event graph, here from this second one, I want to call this update hand visibility for the left hand and then call it for the right hand. So that's why I'm going to add another one here. I'm going to connect the sequence to the first one, update hands visibility, and the second one. First, I want to do basically everything I want to do with the update hand visibility for the left and then for the right. Here I choose right, there I choose left. But anyway, now that I did that, then the first thing I want to do is basically when I do update hands, why did I do that? I grabbed the wrong function. Apologies for that. What I want to do basically draw debug virtual hand, not the other one. Then I'm gonna do it for hand left and hand right, basically. Let's double click here a bit, make this more organized. And then, yeah, basically we are going to do a check here. If, for example, what we want to do if the XR hand left is visible, because we want to only draw the gizmos, because we want to draw basically those debug hands whenever the hand tracking status is active. So how do I know the hand tracking status is active? If I get the mesh for the XR hand left, there's a function called isVisible. If it's visible, then I'm going to basically call this function. That's why I need a branch here. I'm gonna add a branch, then I'm gonna move this one to here. Basically, if the condition is true, if this XR hand left is visible, then I will say draw the debug virtual hand for hand left. Same thing on the other side. If the XR hand right is visible, then that means we are doing the hand tracking. And then I'm going to call is visible. And I'm gonna, in a branch or if, I'm gonna use this branch to basically can select all these together, press Q to basically organize them. So here, basically, I do the same check. Yeah. If this thing, basically this XR hand right is visible, I want to draw debug virtual hand. For the hand right, draw debug virtual hand for hand left. But if we run the game right now, nothing is going to happen because still, basically we haven't implemented these functions. Then basically what am I gonna do? Let's comment this. I'm gonna call right draw the left debug virtual hand. I'm gonna comment the other one, draw the right debug virtual hand. So I'm gonna go inside one of these functions or double click here, it does not matter. Then inside this function, what I want to do is basically calculate the location of every joint, get them, and draw the debug hand, which is going to help us in the future. We'll see whenever we want to animate the hand, it's really useful. And then, so the first thing I should be doing for this one, for the draw debug virtual hand, of course, is to get the hand tracking data, which once I got the hand tracking data, I'm going to use that to draw each one of those gizmos. So what am I gonna do? I'm gonna drag and basically wire from this. I will say get hand tracking status, and inside this one, also I have to provide basically get player controller and specify it as the world context. This is necessary. And yeah, this should be fine. And then once I do that, basically, let's comment this. I will call this get the hand tracking state. Then I'm gonna break the data, break hand tracking data. Then here again, I want to do some verification. Basically, if it's valid, and also we want to check the length for this. If you remember from the first tutorial, we said we have 26 joints in any of these, but I'm gonna iterate one of these basically using for each, and I want to make sure the lengths of these two are equal. In the previous tutorial, we exactly check if they are 26, but here, because I want to draw debug joints, maybe I have less joints, I don't know. I'm doing it for debugging purpose. That's why I only check the equality of these two. So I'm gonna here basically add another and boolean, and also for this one, I'm gonna say equal, and then, sorry, I have to first get the length. I don't have a function called get length. It's called just length. I will get the length for this one, then we will get the length for the other one. And then here we use the equal here. Okay, once we did that in here, basically we use this as one leg of this AND condition. And then once we do that, basically we add another branch to do rest of the work. So I will basically, once I get the hand tracking state, I'm gonna come all the way here, say branch, because we want the execution flow to continue to here. And then we basically, if everything is true, the condition that we had here, if everything is true, then we will continue the rest of the function. So I'm going to grab this and type verify the hand tracking data. Once we did that, then it's basically time to iterate over the joints. As you remember, we said there are 26 joints, location, rotations, and also a scale. We don't care about the scale here. We only care about these two. So here, what am I gonna do? Basically, I have to iterate over this. So I'm gonna add a for each loop. We're going to connect this to this one. And inside this for each loop, it requires an array as an input in order to iterate over every element of that. So What am I gonna do? I'm going to connect this. Let's make it a bit more organized, probably like this, by double clicking, and then, yeah, I think it's good. Then once we did that, basically we want to, inside the array, we want to get a reference. If you remember, I've already said what is basically from this one, basically from the lens, I want to get a reference. I'm gonna call it get ref. Of course, I can get the array element because I'm iterating this one. It's going to return the location for the first element, for the second, third, so on and so forth. But I want to use the array index because I'm using it for the other one as well. So I prefer to keep everything the same way. Let's get a ref. And as I said, we already mentioned in the first tutorial what is the difference between getRef and getCopy. For our use case, getRef is fine. So if you want to know what exactly the difference, please watch the first tutorial. Now, also I want to connect the array index. This is important because otherwise for 26 times this for loop is going to run and I always return the first element, which could create a bug, definitely. Then what am I gonna do? I'm gonna define another function. Basically for every joint, I want to call that function inside this draw debug virtual hand. So I'm gonna add another function. I'm gonna call it draw debug Gizmo. And what I need from this is just, if you go back here, is just the location and the rotation. Of course, I could accept other parameters, but I prefer to hard code them for drawing. For example, the color, the length of the gizmo or whatever. We are going to basically hard code those, but you can always accept them as parameters. But anyway, here I'm gonna add a parameter called location. Then I'm gonna add another parameter called rotation. The location is going to be of type vector for location XYZ, and rotation, which is we are going to use a rotator, not a quad, which are Euler angles. We also talked about this in the first tutorial. But anyway, the only two parameters to this function is basically location and rotation. Now let's go back inside draw debug. Then inside the loop body, I'm gonna call draw debug gizmo, which the function that we just defined, and pass in the location, pass in the rotation. That's it. But this rotation, as you can see, because it's a quaternion, it's going to be, Unreal is going to basically automatically cast this, convert this to Euler angle. But anyway, let's keep this for now. Then we go inside the function. What we want to do here, basically draw a gizmo, which may seem a bit complex, but it's not at all. Just we do it step by step to see how this thing basically works. So the first thing I want to do is, of course, I don't need the location and rotation right away. Then I'm gonna promote these into local variables, and I'm going to call this let's call it, for example, start location, because I cannot just name this location. The reason is, if I do that, because it's already in the function parameter, it's already called location. If I do that, it just brings back the old name, which is start location. I cannot. I should be using a different basically name here. And then here I'm gonna promote also this one to a local variable, which I'm going to call it, let's connect this. I'm going to call this start rotation as well. Let's stay consistent and do not use white spaces here. But anyway, we comment these. We are going to call this cache the start, location, and rotation. So once we did that, and then we need other things. What do we need? How do we know what do we need? Well, if we want to draw a debug gizmo, if you go back into our scene, you see a gizmo here. Basically Z is up, Y is right, and X is looking basically at the direction that we are. Basically it's perpendicular to us, to the viewer. Basically we want to draw 3 lines like this and call it a gizmo. So Unreal has something called draw debug line, as you can see. This draw debug lines, of course, requires a line start, which we already have it. It's called the start location. It's passed to the function. We know this one. It's going to be, the origin is going to be, for all the 3 lines, it's going to be 1 point, which is here. But for the rest, we should calculate it based on a length. We need a length and also the rotation that we are looking at. For example, if the origin is here, on my screen, as you can see between this line, I need first the rotation, which direction the end of the line is. So I should know which basically angle I am rotating, and then also a length for the vector. So that's why I also need the length and also need the rotation to calculate basically the end of the line. And we are going to do that with the rotation and a length. So the first thing now then we need is called length, which is of type float. So let's say I want to keep them 1 centimeter or maybe 1.5 centimeters, because we are going to basically 15 millimeters, because we are going to draw a mesh. We want that to still be visible, not inside the mesh. So I'm gonna make it a bit longer. You can of course make it much longer, but I think they will basically conflict with each other and overlap basically. So 15 millimeters is okay in my book. And then also we want a line color. And in addition to the line color, we also need a duration and we also need a thickness. So then also we need end. As we said, we also want to calculate that. So I'm going to basically call x-axis end. This one is going to be of type vector because this one also requires a vector. Then I'm gonna call another one like this one, call it x-axis end, y-axis end, and z-axis end. Okay, now then we have a length, we have the rotation, of course, we are going to calculate these 3. Then we need a line color. Then probably I'm gonna call this x-axis color. I'm gonna type this linear color. So then we are going to have a x-axis color and a y-axis color and a z-axis color. Okay, for these ones, we did already hard-coded the length. Of course, as I said, you can accept it in the function, but you can also accept the colors as well. But for the rest, we can calculate it from the length. And this one, also, I'm going to hard-code the x-axis. Let's make it red. And also do not forget to add the alpha. Alpha should be 1, otherwise it's transparent, as you can see here. Then it will be red. Let's go back. You see for the x-axis it's red, for y it's green, for z it's blue. It's usually like that, at least inside Unreal Engine. So here I'm gonna go for y, make it green, also alpha 1. So you see that. Then for the z-axis, I'm gonna make this 1. So now I have the line colors as well. Now we need 2 other parameters. The other one is called duration, which is a lifetime in seconds. Basically, it's a float that says for how long this line should be drawn. We basically, when you run your game or you have an animation, you have frames. And those frames, when they are basically being those sequence of frame, when they are played back to back, they are played, they create like a illusion of a smooth, basically animation. So the time between those frames, it's called delta time. We probably want to keep the duration something close to the delta time. Not exactly the delta time, because if I put 1, sometimes it could disappear. It's just not very stable. So that's why I'm going to define a variable. I'm going to call it lifetime modifier, and use that lifetime modifier to basically draw the basically calculate the duration or lifetime. So I'm gonna add something called lifetime modifier. I'm gonna make it float. I'm gonna make it 1.1. Then I'm going to have basically another variable. I'm going to call it lifetime. Then we will calculate this based on the frame rate. So I don't have to specify this. But I did specify the lifetime modifier. Also, you can make it a parameter to this function, but I don't think it is necessary. Then also we need the thickness, which is basically here. It's how thick your lines are going to be. I think 1 centimeter is too much, because we already specified like 1.5 for the lens. So probably something like 2 millimeters should be fine. So I'm gonna add like 0.2, which I believe it's a reasonable thickness to have, but you can of course change it. Anyways, these were everything that we needed for every basically draw debug line, and we have to call this function 3 times. But in order to call this function, we still don't have these 3, and also we don't have the lifetime, which is the duration. The rest we do have them. So it's time to basically calculate the lifetime first. Then basically once we cache the location start and the rotation, what am I gonna do is going to call a function called get world delta seconds, which I'm gonna basically use to get the delta time between those frames, which means the time between each frames being drawn. And then I'm gonna multiply that by lifetime, which we did already here. Sorry, by lifetime modifier, which was 1.1 in our case, as you can see on the details panel here. Basically, we make the number a bit bigger, just a small bit. So once we do that, we are going to set the lifetime variable. So this is how we calculate the duration of the basically lifetime of the line. So once we did that, we are going to assign that to the lifetime. Then let's comment this and calculate the lifetime. This is of course too much work to do the Gizmo, but it's going to be really helpful. Then we need to basically now calculate the x-axis end, y-axis end, and z-axis end. And in order to do that, first we need to get the start location, which is any location in the world of the joints that we have on the hand. Then once we did that, we are going to also add this number by something. By what? As I said, imagine this is your start location here. You want to have a rotation, basically, and then that rotation is going to be added by a length. So what we do, we get the start rotation, and once we got the start rotation, we are going to draw a line out of this. We say rotate vector. As you can see here, this function basically returns a result of vector A rotated by rotator B. That means we have, we want to basically create like a vector, but it's rotated by this rotation, and we want to add it to the start location. So what we're going to do is we have the start rotation. I'm going to split this struct because I only want to add this on one axis. So what am I going to do is going to grab the length, which means for x-axis, I'm going to basically assign this to x. What does all this mean? Let's see. Again, I'm going to show it visually here. I don't have a pen or something to show it to you, but we say we have the start location here. We want to add it by something at some direction. What we do, we have the start rotation. We only have a rotation. Then we want to add it by a vector. We are going to only add that vector on the x-axis, for the x-axis of the basically rotation. Then we ignore the y and z, and we do the same thing for y-axis and z-axis. We are going to add that to y and z and then ignore the rest basically. And we are going, whatever vector it just results, we are going to add it to the start location. So it's going to draw a nice gizmo for us here. For example, we say we are here. We want 1.7 in length in z direction, 1 point in y direction, 1 point in x direction. So this is basically the same thing that we are doing here. I hope that clarifies it. We are going to say add vector. Just as I believe this add should be enough. Okay, now what am I gonna do? I'm gonna grab this x-axis from here, set the z-axis. So basically what we are doing here, we calculate the end of the x-axis. So I'm gonna select these, call this commented like calculate the end point of x-axis. Then let's duplicate this. Now it should be easy. Oops, we messed up. I'm gonna Control C, Control V, move it here. Then I'm gonna create another one. First, let's change the comment. This is going to be Z. This is going to be Y, so it's not misleading anymore. Now, we are gonna select these, connect these for Y to this one, but disconnect it from that one. So, and also this one should be y-axis. Set the y-axis after we calculated it. We're going to do it here, and then for the other one I'm going to disconnect one, but I'm going to connect it to z-axis, and we set the z-axis end. So I hope this is now obvious. What am I doing here? So basically what we did, we calculated x, calculated y, and we calculated z, basically the location. So once we did that, and we have everything to basically draw the x-axis, and then we draw the y-axis, and then we draw the z-axis. So what am I gonna do? I'm gonna call draw line or draw debug, maybe line here, and then I will connect the rest of this. So the execution flow, after we calculated everything, we are going to use everything we have. Get start location, get x-axis, and then we want x-axis color, which we already do have it. No need to calculate it. Then for this, the other one, duration, we use the lifetime, and for the thickness, which we already specified 0.2, which is 2 millimeters. So now we have the x-axis drawn. Let's comment these. Call this draw the x-axis. Okay, now I'm gonna duplicate this, then maybe duplicate it like this, connect this, again duplicate it, connect this, fix the comment first. Then we are going to fix this one as well. Now, we only have to delete these two, delete these two. Okay, z-axis color, which we get it here. It's for z, and then z-axis end, which we give it to the line end. For the other one, this one, we are also going to do y-axis color and y-axis end. So now I believe everything is fine. I can save it. There's no compiler error. Then we go back here. We already called draw debug Gizmo. I believe everything should be working if we've done everything correctly. I will put on my VR headset and probably have to launch MetaQuest link again. Wait a bit. And now that I have it, I'm gonna basically stop. Let's go to VR preview. Well, as you can see, we have nice debug hands here. I can move around and do whatever I want. It's just like the cube, but it's nicer because it actually tells us, because the cube were not telling us anything about the rotation in the world, but now using the gizmos, actually, I could see if I basically, when I animate the hand, I could use these as guides if I do everything correctly. And at the bottom of the page, as you can see, there are the virtual hands, basically the ones that are from the hand tracking. If I touch the controllers, as you can see, both the mesh at the bottom and the debug hand disappear. But only one last thing is remaining, and that is I want to basically, whenever I press the D key, I want to turn on off the debug virtual hands that we have here. So for that, let's stop the VR preview. I will go back inside VRPawn. Here, what I do, I'm going back inside the event graph here. I will define a variable of type Boolean. Let's call it, for example, we could call it bdraw debug virtual hands, bdraw debug. I cannot type bdraw debug virtual hands and make it a Boolean. Okay, now what I want to do is at the beginning of the game, let's go back to event BeginPlay here. What I want to do, let's move this a bit to the right. I'm gonna add a debug message here. I'm gonna say print a string. Let's make it yellow, for example. I could press 1, 1, 0. This should be yellow, alpha 1. So this is yellow. And then here I'm gonna increase, for example, to 8 seconds. Compile, save this. And then I want to basically show a message here. I'm gonna say press D on your keyboard to toggle the virtual the debug virtual hands on or off. Okay, if I save the game and if I play here, you can see at the top of a screen, although it's a bit like really small. For example, if I play inside the viewport, you can see it here. We show a message for 8 seconds to the user. Of course, it's just a message. We haven't yet handled the basically D key. So here underneath, basically above that even, I could here type key D, then I'm gonna come here and choose D, and whenever this is pressed, I'm gonna add a flip-flop. What is a flip-flop? Basically, the flip-flop is a node that is going to one time when it's triggered. One time, for example, when I press D, one time it runs A, the other time it runs B. So the first time it's pressed, I assume, because here I assume you've chosen false. As you can see, this is the default value. Whenever it's pressed, basically the first time here, I'm gonna say set it to true, which means it's going to enable it. The second time it's pressed, I'm going to make it false. That's it. That's all we need in order to disable debugging and the variable in terms of like pressing, handling the keyboard input. We set this variable, but here we go back to here, this part where we were drawing the left or debug virtual hand, the left or right. Here, basically, what am I gonna do? I am gonna check the value of the variable. Let's expand this a bit, also this one. And then basically we could drag this here and use the AND boolean. If the mesh is visible and also the draw debug virtual hand is basically true, we are going to run this condition here. Let's again expand this a bit so it looks nicer now. Now, that's, I guess, the only thing that we need in order to make this work. Let's say and boolean. I'm gonna connect it to that one, then connect this one as the first input, and then we do it like this. We go here, and that's it. That's all we need. And now compile, save. And when I basically, I have to put on the headset again, wait for Meta Questlink app. Okay, now it's running. I'm gonna VR preview. And as you can see, now although I can see now the controller is active. Now my hands are active, but as you can see now, I can see the mesh at the bottom of the basically floor, but I am not able to see my hands because basically it's toggled off. But whenever I press D, I can see them. As you can see, my right hand is on the keyboard. You see the location. I press D, it's turned off. I press D, it's on, D off, D on, D off. So we achieved the first part of the tutorial, which was basically drawing the debug gizmo and toggling between the controller and the hand tracking, basically hand meshes. And in the next part, we are going to focus on animating the hand and adding the gesture functionality that we had earlier. I hope you've enjoyed this tutorial. If you'd like to follow more content like this on my channel, please subscribe to the channel and hit the bell icon in order to get notified. And I hope you've enjoyed the tutorial. See you on the next one.